So we've studied so far that when water quantities need to be reduced, mostly when weather cools down or days are getting shorter, if you're on drip irrigation, it is not advisable to cut water quantities, but rather extend the gap between irrigation sessions. We do it because we don't want to change the boundaries of the dripper's wetted bulb. And now comes the question by how much this gap, which was classically daily, can be extended. And to calculate this, we must find how much water we have in the available irrigated volume when it is fully saturated, and then divide it by the daily return rate. We have already studied the AIV, the available irrigated volume, and the subject of return rate was widely discussed in the Introduction to Modern Irrigation course. What remains is A, finding the soil capacity, B, do the calculation properly. Those of you who did soil and capacity in your agricultural studies must remember a long and complicated process, so complicated that in many cases people refrain from doing it. But in this video, we will present a simpler way that might even prove to be more accurate. We start with collecting samples from our field. In any case, but particularly if there is obvious soil variation in your field, we will take 3 samples that are nicely represent the various soils in the tested plot. For the sake of this experiment, I deliberately used extreme differences when one is the quartz sand that usually used for construction, and on the other end, a heavy clay soil which comes from the bedlands around me. The soil must be dry enough to freely go down a rough strainer, and that's exactly what we are doing with it. Pass it through a strainer. We screen out exactly 1 liter. Note that A, I do not demand a complete drying of the samples, but I do advise leaving it in your oven at 100 degrees centigrade for 1 night. Some of you may question that, and the answer will come when we will process the results. I'll give you a hint. The wilting point that we're going to calculate is very far from the current state. B, the samples are 1 liter and not 1 kilogram. Although in this experiment we do an extensive use of scales, we are dealing eventually with volume here and not with mass. It is our luck that 1 kilogram mass of water is exactly 1 liter. Besides the samples, we will need 3 empty clean soda bottles, a hand drill plus 4 mm bead, or a 4 mm nail plus a burner to heat it, 1 kilogram of thin gravel, 1/4 square meter of fine insect net. Try to find the finest. This one that I'm showing here is 50 mesh, a funnel, a pair of scissors, kitchen scales, and a marker. We're also going to need about 2 liters of local water. We start by drilling 10 holes at the bottom of each bottle. Use the drill or the heated nail carefully, but make sure the holes are close enough to the bottom so that no water remains locked, as it might bias our results. Now we fill 2 handfuls of gravel into each bottle. With the insect net, we want to mark 6 circles on the net, slightly larger than the diameter of a bottle, to be used as a membrane so we won't lose our soil. The funnel is a good tool for that. Mark and cut. Now take 2 circles together, roll them into the bottle, and then flat them above the gravel at the bottom of each bottle. You may use a long stick for this. We are now ready to fill the soil samples, 1 into each bottle. Use the funnel and carefully tip the soil in. Use the marker to mark each bottle as sample 1, 2, and 3 respectively. Weigh each bottle after filling and write its dry weight in grams on the bottle. Time to fill the water. This process may take some time. Keep adding water until you see that the soil is fully wet, and then another 3 to 5 centimeters of water above the top of the soil. In my case, since the samples are so different, even the filling requires returning several times. Once you reach saturation, plus some water above, you can leave the water to percolate down through the soil, gravel, and out of the holes that we made earlier. Check it again after 1 hour to see if the samples are ready for saturated weighing. I had to wait the whole night, and it might as well happen to you too, depend on the type of your soil, because one of my samples was late bleeding, and I came this morning, and now we can check, verify that no sample is oversaturated. We do it by holding them up and make sure that for about 1 minute no drops are coming out of the holes. And if this is okay, we can now start weighing them. Weigh the samples one by one and write the results either on the whiteboard or on the bottle itself. Write it still in grams. Later on we will do the calculation. Once we got all the results, we can now calculate. We deduct the dry weight from the saturated weight, and the results that we get them still in grams. But now what we're going to do, we're going to divide by 1000, and then we get the ratio. The ratio is the amount of water that we have in 1 liter of soil, the amount in cc. It is ratio because gram of water is cc of water, and cc of liter of soil means that this is the exact ratio of water per soil. Our next step is to calculate it all and find out how this data help us to determine the extension between irrigation, how long we can extend the gap between irrigation. And for this we have to put it on a much more complicated calculation where we take in account all the other aspects of the field, the size of the available irrigated area, and the return rate that come in result. We will do it all in the upcoming class, and to do this we have to download the Excel from my website and follow it.